Good morning, my dear students. Myself, Kausar Momin, 8th Standard, Subject Science, Chapter number 16 Reflection of Light. We get different feelings through senses. The sense of vision is the most important among our five senses. Because of this, we can see the hills, rivers, trees, people, and objects around us. Only with this we can see the beautiful views of nature like clouds, rainbow, flying birds, moon, etc. So this is happening because of our sense. And here sense is likewise with the help of eyes you can observe all these things. Could you see the objects in the room clearly when the light was switched off? Obviously no. And what did you feel when it was turned on again? That means we can able to observe the things which are present in our room. When the presence of light is there, at that time only we can observe it. So we can say with the switching off or switch it on conditions, if you do this activity, so you are able to understand the concept, which is when the presence of light is there, then only you can observe. So what is the concept is behind it? So we can say that there is some connection between sense of vision and light. Obviously if the light is there, then only we can observe. So we can say the connection between sense of vision and light. When we switch off the light at night, the objects in the room cannot be seen, and they can be seen as before when light is switched on again. Thus we can see objects when the light coming from these objects enters our eyes. The light entering our eyes may be emitted by the object or may be reflected by the object. So the mean is we can understand this, that we can learn the concept of reflection of light. Any object which you can observe, light enters with that object and same ray wanna go come to our eyes. So this concept is reflection of light. How exactly we can understand reflection of light and how to define exactly reflection of light? Let's go ahead with the definition. This is very important. Reflection of light. When light rays falls on object, their direction changes and they turn back. This is called reflection of light. To understand definition, we will go ahead with one activity. To understand this concept, we are taking one normal paper, mirror, pencil pen, laser light and protector. So what we are doing over here, the laser light rays are gonna fall on that mirror, and whatever the reflection is there, that we are getting at normal paper, plain paper. Here you can observe when the light ray is falls on paper, it is creating an reflection. This is light ray, which we are naming it as incident ray, which is falling on the mirror. And after the reflection, we are getting a reflected ray. This is the reflected ray. Between this incident ray and reflected ray, a perpendicular line is passing. That line is called as normal. And incident ray is creating an angle with the normal. That angle is called as angle of incidence. And reflected ray, based on the same, you can make incident ray, reflected ray and normal. Normal is at 90 degree. This is the way to write incident angle and reflected angle. Angle of incidence is creating with incident ray, An angle of reflection is creating with reflected ray, and both are equal. You can observe here. See, at whatever angle is coming, with the same angle of reflection is also creating. So this is the ray diagram for reflection of light, which we have seen the activity. Incident ray falls on the mirror. Reflected ray is coming back with the opposite direction with the same path, and normal is there in between these two rays. Incident angle is creating an angle with angle of incidence, and reflected ray is creating an angle with the normal, which is angle of reflection. Both are equal. Angle I is equals to angle E. Angle of incidence is equals to angle of reflection R. Based on this, some terms are related. Very first term is ray AO is the incident ray. Point O is the incidence, point of incidence. Ray OB is reflected ray. Line ON is normal. Angle BON is between reflected ray and normal is called as angle of reflection. Angle AON is between normal and incident ray is called as angle of incidence. Which activity we have performed previously? With that activity we have seen this one. We have drawn this angle. So we can say whatever the angle of I, that much is angle of R. If angle of I is 30, then angle of R is also 30. Angle I is 45. Angle R is also 45. 60, and here also we are getting 60. Always angle of incidence and angle of reflection are equal. Next topic is regular reflection of light. With our daily life, rays falls on each and every object, but somehow we are able to see the reflection, and somewhere we are not able to see the reflection. If it is a part of mirror or any smooth surface, we are able to see the reflection of light. So here you can observe, if it is a part of wall, then it is not a smooth surface, rough surface is there, and the light which falls on light rays which falls on the rough surface, which is we can see it as diffuse reflection, because whatever rays falls on it, they are not having properly reflection. So let's go ahead for the closer look for beam of light. Any light rays which falls on any object with a parallel, they are having their reflection. You can observe here yellow lines and blue lines. All rays are parallel. This is regular reflection. If rays are parallel with each other, whatever angle of incidence and whatever angle of reflection is creating over there, all are equal. Suppose here with this angle, angle of incidence and angle of reflection. For this, another ray, angle of incidence, angle of reflection. So this I1, here I2. With every ray, I1, I2, I3, all angle of incidence are equal, and all angle of reflection are also equal. Likewise, we can say I1 is equals to I2 is equals to I3, and so on. Similarly, R1 is equals to R2 is equals to R3. All angle of incidence and all angle of reflection are equal. Such reflection is regular reflection. So for the same reason, we are able to observe the object which are present in our house. Or similarly, you can observe your image in the mirror, because that is also a regular reflection. But when it is coming about a wall, rough surface is there, and when the light rays falls on that rough surface, they are not having equally angle of incidence. You can observe here when light falls on this rough surface, they are not parallel. So we can say when parallel rays do not remain parallel after reflecting off a surface. You can observe they are not remain parallel. So whatever angle of incidence you are creating, all are equal, but reflections are not equal. So this reflection is called as irregular reflection, or another word for irregular reflection is diffuse reflection. When light falls onto a rough surface, it obeys the laws of reflection. It obeys the laws of reflection, but not equal. Here we can say I is equals to R, but all reflections are not equal. Likewise, R1, R2, R3 are not equal. But for specific ray, whatever angle of incidence and whatever angle of reflection is creating over there, they are equal. So similarly, this can be example of your wall. So that is why on your wall you are not able to observe the reflection, but you can observe that wall because of rays which are falling on the wall, they are coming to your eyes. So here is the ray diagram for the same regular reflection of light, and which is coming with two part. One is smooth surface, another one is rough surface. With the smooth surface you can observe I1, R1, I2, R2, I3, R3. All angle of incidence are equal and all angle of reflections are equal. But when it is coming about rough surface, in the rough surface they are not equal. Here you can observe the condition. With the smooth surface, all angle of incidence are equal, all angle of reflections are equal. But when it is about irregular surface, which is rough surface, which is irregular reflection, here I1, I2, I3 are not equal with R1, R2, R3. Next we will go ahead with new topic, which is reflection of reflected light. For this concept we have to understand based on one activity, and this activity is about kaleidoscope. So how to make kaleidoscope, let's go ahead with this. Here we are going ahead the construction of kaleidoscope. We are taking three mirror with same size. We have to make a triangle. Based on this three mirror, we have to take a sellotape. With the help of sellotape, we can make a triangular shape with these mirrors. Here we are taken three mirrors. Now join all the three mirrors. Likewise, whatever the reflection surface is there, which should be inside of the rectangular shape, and we have to make the tape should be along with this mirror only. You can observe what we are making kaleidoscope. In this, we are able to observe the reflection of light, how is happening with the objects and all. Now we can make any kind of paper which should kaleidoscope should look attractive, and we are sticking that paper on the same. And whatever triangular part is there, we have to stick over there a transparent paper. You can observe here the paper is little bit transparent. The light rays should cross this transparent paper. Likewise only we have to arrange this setup, and then one side should close with the cardboard paper. So we are making that cardboard with a triangular shape, and one hole we are making over there to observe what is there inside of that. Now we are keeping inside of that mirror few objects, small stones and all. Likewise, we are able to observe their reflection clearly, and we have to close the another end also. One hole we are keeping over there for the observation. What observation is there? Observation of the reflection of light and how we are observing the stone. The stones we have to observe, and the reflection part of the stones also. So this is your kaleidoscope. One side is transparent paper is there. So interior, you can observe this interior look. Inside of that we have seen the reflection, and due to the reflection of light, the stones which are over there, for the due to the reflection we have observed with respect to one stone many more stones. Now next activity is periscope. Here you can observe periscope construction is like take a cardboard, make slits in the top and bottom sides, place the bottom mirrors and they make 45-degree angle of slides box parallel to each other. This is the mirror and this is the mirror. We have to attach this mirror. When you are observing from this side, then you're able to observe this side things in this mirror. How? Because this side's things are gonna come with this mirror, and this mirror's reflection is coming over here, and that reflection you are observing. So this is periscope. Let's go ahead. This is the periscope construction part. So we have to arrange all these cardboards in this way. As you can observe, we have done two sides for to fix the mirrors with 45-degree angle. Here you can observe. Now fixing of mirror part is there. Another mirror also we are fixing. Here is the next mirror. You can observe their direction. 45-degree angle is there. Now we are closing the opening end. Inside of this box there is a two mirror inside in it with the angle of 40 degrees. See, from this side you cannot observe anything, but when you are keeping your hand with the another side, you are able to observe that image with this side. So this is periscope construction. Use of the periscope will be there in submarine. So from the bottom window, one can see what is front of the top window. This device is called as periscope. This is used in submarine to object the object surface of water. It is also used to observe and keep a watch on objects or persons on the ground from the underground bunker. Kaleidoscope and periscope both use properties of reflection of lights. Here your chapter gets over. Now numericals are there based on the same. First numerical is if the reflected ray makes an angle of 60 degree with the normal, what angle must be incident ray make with the normal? Reflected angle is given 60 degree. We have to find out angle of incidence. We all know according to the law of reflection, angle I is equals to R. If R is 60, then I is also 60. So we can say incident ray will make an angle of 60 degree with the normal. Okay. Next is if the angle between the incident ray and reflected ray is 90 degree, what are the values of the angle of incidence and angle of reflection? If that angle is 90 degree, that means we can say their addition is 90 degree, because it is given this way, angle of incidence and angle of reflection. This angle they are giving 90 degree. So this is angle of incidence and this is angle of reflection. Addition of both is 90 degree. So according to the law of reflection, both angle are equal. Angle I is equals to angle R. So instead of this R, we can keep I. So angle I is equals to angle I, which is equals to 90 degree. Why we are taking this angle I? Because instead of this R, we can keep I, because both are equal. So 2 times of angle I is equals to 90. This 2 is going to get divided with 90, and angle I we are getting 45 degree. If angle I is 40, then definitely angle R is also 40, because according to the law of reflection, angle I is equals to angle R. Okay. Remaining sum you have to solve, sum number 3 and sum number 4. If any doubt, please ask me. Thank you.